Uh, a nice inequality from IMC 1995 problem 2. Let f be a continuous function on 0 to 1 such that for every x belongs to this domain we have integral from x to 1 f of t greater than 1 minus x squared by 2 so that this holds. So we'll try to solve this by two different methods. Yeah, in both of the ways basically we have to show that this holds. Yeah, and the first one is basically Cauchy-Schwarz. Yeah, Cauchy-Schwarz. So how do we you deal with this using Cauchy-Schwarz? So let's take this integral from 0 to 1 f squared t dt. Yeah. We want to show this greater than some other functions raised to 1 by 3. Let us also add integral from 0 to 1 of t squared dt. Yeah, basically 1 will not do anything, so t I have done. This is greater than equals to, now by Cauchy-Schwarz, integral from 0 to 1 f of t times t dt whole square. Yeah, basically Cauchy-Schwarz implies this. Yeah, in the sum form it was basically the sum of a squares sum of b squares greater than equals to sum of ab. It was something like this. Yeah, and in the integral form it's like this. Okay, and now this is just 1 by 3 integral from 0 to 1 f squared t dt. Yeah, greater than equals to. Now how do we deal with this integral? We are given this thing and this thing needs to be used, also this needs to be solved. So basically we can try to convert this to a double integral from 0 to 1 and then integral from let's say 0 to t of f of t dx dt. I can make it like this. So basically what I'm trying to do is using this t thing to convert to a double integral. Yeah, basically this is just constant, so here will be x from 0 to t and t minus 0, so this thing will be there. Now what I'm trying to do is, if I try to like reverse the limits of integration, yeah, this will basically go from x to 1. You will see that, and that will help. So basically here we have t and x. Yeah, and t is going from 0 to 1 and x is going from 0 to t. X is going from 0 to t. Yeah. Okay, and now if I have to change the way I have seen, like if I try to like see it in a horizontal way, this will be uh, okay, currently okay, so currently t was going from 0 to 1. Now let's say x is going from, okay, so originally I was looking horizontal, now let's look at vertically. X is going from 0 to 1 and t is going from x to 1. Yeah, so basically now t is going from x to 1 and x is going from 0 to 1. We have interchanged. Yeah, now notice that this thing is just given here. So this is greater than equals to integral from 0 to 1 of 1 minus x squared by 2 dx. Now evaluate this. Yeah, now evaluate this one and you get that this over here is just 1 by 3. 1 by 3 square is 1 by 9. So see, it's proved now. Integral from 0 to 1 of f square t dt is greater than equals to 3 by 9. That's 1 by 3. And it proves the statement. Yeah. Okay, and but let's see the second proof as well. How does the second proof go? In the second proof, we basically start with this expression integral from 0 to 1 of f of t minus t dt whole square. Now since the integral is going from left to right and this height is positive, the overall value will be positive. It is greater than equals to 0. Yeah, now this integral is actually integral from 0 to 1 f square t minus 2 times integral from 0 to 1 t f of t plus integral from 0 to 1 t square dt. Also add dt over here in all of them. This is greater than equals to 0. Yeah, and that implies integral from 0 to 1 of f square dt. Now we again get this thing is greater than equals to 2 times integral from 0 to 1 t f of t dt minus this is just 1 by 3. Yeah, 1 minus 1 by 3. Now again use the same thing. You can write this as integral from 0 to t of f of t dx dt. Yeah, minus 1 by 3. And now this is 2 times integral from 0 to 1 integral from x to 1 of f of t dt dx. Yeah, just like we did earlier, dt dx minus 1 by 3. Now integral from x to 1 of f of t dt is 2 times integral from 0 to 1 of 1 minus x square by 2 dx minus 1 by 3. Now this integral over here, that's just 1 by 3. Yeah, so 2 times 1 by 3 minus 1 by 3, that's just 1 by 3. And we have solved the problem in 2 different ways. So to use Cauchy-Schwarz, I think one of the attempts with variable you can make is just t. So you should like be noticing, you should be getting this in some time, and it should not take a long time. Yeah, and this proof, these are some just general ideas, and you are likely to try with t in many of the integrals, so you should be getting this idea. And it's not like too like unthinkable or something like that. It's thinkable and somehow doable as well. Hope you enjoyed the video. Hope you enjoyed both the proofs. Thanks for watching. Look forward to seeing you in the upcoming videos too.